Good evening. So in this class, we will discuss two problems on Fourier transform. So first problem is find the Fourier transform of e power minus a into mod x, and hence deduce that subdivision number one, integral 0 to infinity cos xt by a square plus t square into dt. So this is the first unit is. I'll write the answer also. Answer for this problem is pi by 2 a into e power minus a into mod x. So this is the first subdivision, and then I will write the third subdivision, and then I will write the second subdivision. Third subdivision is Fourier transform of x into e power minus a into mod x Okay, you need to prove this is equal to I into root 2 by pi two as by s square plus a square whole square. This is subdivision number 3. Subdivision number 2 is subdivision number 2 is I should reduce the value of integral 0 to infinity 0 to infinity dt divided by dt divided by, or you can write dx divided by, okay, dx divided by x square plus a square, x square plus a square whole square. So the value of this integral is pi by 4a cube, pi by 4a cube. Okay. So first we will solve this problem, and then we will solve one more problem in this class. Now solution. I'll start the solution. So the solution, first write the definition of Fourier transform of f of x. Fourier transform of is right. The Fourier transform of f of x is what? E power a minus mod x. Okay, e power minus a mod x, which is equal to 1 by root 2 pi minus infinity to plus infinity. Okay, minus infinity plus infinity e power minus a mod x into e power isx, e power isx into dx. Okay. So now we can write this is equal to 1 by root 2 pi minus infinity to plus infinity e power minus a into mod x. E power isx is what? Cos sx plus I sin sx into dx. Okay. Now, so we know that this is a what? Even function. Okay, I'll write in the next page. It is equal to 1 by root 2 pi is common minus infinity to plus infinity e power minus a mod x into cos sx dx. E power minus a mod x into cos sx into dx plus I into integral minus infinity to plus infinity e power minus a mod x into sin sx dx. Sin sx into dx. Okay. So we know that this is an even function. So this is also what? Even function. So even function into even function is even. This is what? Even. Sin sx is odd. So even into odd, you get what? Odd function. The second integral is 0. The first integral you can write it 2 times 1 by root 2 pi 2 times integral 0 to infinity e power minus a mod x into cos sx dx. Okay. Now, so the x value is what? Only positive value, 0 to infinity. So you can write this is root 2 by pi. The values of x are positive. That's why modulus of x is equal to x in this interval, 0 to infinity, e power minus a x into cos sx into dx. Cos sx into dx. Okay, now you should use the formula which you studied the previous semester also you studied. Integral e power ax into cos bx dx. So that is equal to e power ax by a square plus b square into a cos bx plus b sin bx. B sin bx. Okay. Now using this here a is what? Minus a, b is what? S. So I will write here, which is equal to root 2 by pi e power minus ax by a square plus b square. Minus a whole square is what? A square plus s square into a is what? Here minus a. So minus a cos b is what? S sx and then plus b. B is what? S into sin b. B is s x. Close this bracket and close this bracket 0 to infinity. Now I'm going to apply the limits. So root 2 by pi, e power minus infinity is 0, but here I have x and here I have x. But cos sx and sin sx are bounded function. That means the maximum value of cos and sin are what? Plus 1. And the minimum values are what? Minus 1. So that's why 0 into, because e power minus infinity is what? 0. 0 into some finite quantity is 0. So the upper limit is 0, root 2 by pi. So the upper limit is what? 0 minus lower limit. Lower limit is what? E power 0 is 1. 1 by a square plus s square. 1 by a square plus s square. And then put here x is equal to 0 means what? Cos 0, 1, 1. So minus a, sin 0, 0. So minus a into minus a. And close the bracket. So now final answer, Fourier transform of, what is the question? Fourier transform of e power minus a mod x. E power minus a mod x, which is equal to a by, root 2 by pi, root 2 by pi into a by s square plus a square. S square plus a square. I call this is equation number 1. The first part is over. So look at now, actually this is nothing but you can say this is function of s also. You can write this is function of s, f of s. I call this is equation number 1. Okay, now look at the deduction part. The first reduction part, you have cos xt by a square plus t square dt. So now here the denominator is what? You can see here t square plus a square. Okay, so here also what? S square plus a square. So more or less the same. Okay, that's why now I am going to derive the first reduction part. I am going to use inversion formula. By inversion formula, so what is inversion formula? Actually, 1 by root 2 pi minus infinity to plus infinity f of s. F of s is what? Root 2 by pi a by s square plus a square into e power minus isx. E power minus isx is what? I'll write directly. E power minus isx is cos sx minus cos sx minus I sin sx into ds. Okay, this is the left hand side. The right hand side is what? F of x. Actually, f of x is here what? E power minus a mod x. E power minus a mod x. Okay. Now, root to root gets cancelled. You'll get what? 1 by pi. 1 by pi. So 1 by pi into integral minus infinity to plus infinity a by s square plus a square into cos sx into cos sx into ds minus I into integral minus infinity to plus infinity a by s square plus a square into sin sx into ds, which is equal to which is equal to e power minus a mod x. Okay. So again, we know that this is what even function cos. I think here okay. Here I write only cos x. This is what cos sx. Cos sx. So this is a even function in S. This is also even function in S. So even into even, even. So here what? This is even. This is what? Odd. So even into odd, odd. The second integral is odd function. So this is 0. This one you can write 2 times 0 to infinity. I'll write in the next slide. It is equal to 2 by pi 0 to infinity, 0 to infinity, a by s square plus a by s square plus a square into cos sx into ds, cos sx into ds, okay, which is equal to what? It is equal to e power minus a mod x, e power minus a into mod x. Okay, now I need only this integral value. So I'm going to change the dummy variable. Actually, please check it what we need. Cos s x t. So in terms of t, I need. Okay, wow. So from s to I'm going to change the dummy variable t. Changing the dummy variable s to t, will get cos x. Instead of s, I'll change the dummy variable t. Cos x t by what? uh, t square plus a square, t square plus a square into dt, which is equal to pi by 2a, pi by 2a into e power minus a mod x. So this is I call equation number 2. So this is the deduction part. You can check it again. We'll check it. Uh, Pi by 2a e power minus a mod x. Yes. Pi by 2a e power minus a mod x. This is the answer. The integrand is what? Cos xt by a square plus t square into dt. Cos xt by okay, t square plus a square into dt. So we derived the first reduction part. Now we are going to derive the second reduction part. So second reduction part is what? Integral 0 to infinity uh, dx by x square plus a square whole square. So x square plus a square whole square. So here you can see this is not here square of you can see f of s. What is f of s? So you can see here x square plus a square only. But in the reduction part here I have whole square. So to derive this the value of this integral, we should apply Parseval's identity by Parseval's identity. So what is Parseval's identity? Integral minus infinity to plus infinity modulus of f of s whole square into ds, which is equal to minus infinity to plus infinity modulus of f of x whole square into dx. Okay, so now which is equal to uh, minus infinity to plus infinity. F of s is what? Here f of s equation number 1. So if I square this one, what will get? 2 by pi into a square by s square plus a square whole square. 2 by pi 2 by pi a square by s square plus a square whole square. A square by s square plus a square whole square into ds, which is equal to integral minus infinity to plus infinity. So f of x is in this problem e power minus a mod x. If you square that one, you will get what? E power minus 2 into a mod x into dx. Okay. Now I will first simplify the right hand side. So here you can see again e power minus 2a mod x is an even function. So that's why you can write 2 times 0 to infinity. So right hand side only 2 times integral 0 to infinity 0 to infinity e power minus 2a mod x e power minus 2a mod x, but mod x is equal to x in this interval 0 to infinity. That's why I'll directly write x dx. So I'll write the left hand side also. Left hand side is what? 2 by pi 2 by pi a square also I'll take it outside. A square integral minus infinity to plus infinity. Okay, so here also I can use, this is an even function. What is even function? Again, you can write what? This is also what? 2 times 0 to infinity. So 2 into 2, 4. I can write 4 here. 4, 4 by pi a square, 0 to infinity. Okay, dx by s square plus a square whole square. Ds by s square plus a square whole square. So now, which is equal to 2 times, if you integrate this, you'll get e power minus 2a x divided by minus 2a. The limit is from 0 to infinity. So 2 gets cancelled. Minus 1 by a. Upper limit e power minus infinity is 0. Minus lower limit e power 0, 1. So you'll get 1 by a. But I need only this integral. Okay, look at, but see the reduction part. Reduction part. Here I have in terms of x. So dx by x square plus a square whole square. Change the dummy variable from s to x. We'll get the next step. I'll write s to x integral 0 to infinity dx by x square plus a square whole square, x square plus s square whole square, which is equal to cross multiply pi by 4a square. Here we have a, so 1 by a. Okay, pi by 4 a cube. That's all. So this is equation number 3. So second reduction part is also over. Now third reduction part. Actually, third reduction part is yes, Fourier transform of x into e power minus a mod x. Okay, this is the fourth reduction part. For this, I'm going to use the property. Maybe the first lecture we discussed the properties. First, I will write the question. Third subdivision. Subdivision number 3. Okay, where subdivision number 2 starts. So here subdivision number 2 starts. Solution. Subdivision number 1 here by inversion formula. Okay. So subdivision number 3. So we need to find what? Fourier transform of x into e power minus a mod x. So this is I need to find. First, before this, we need a result. That is we proved in the first lecture. Just I will recall you. So we know Fourier transform of x power n into f of x power, this is n, okay, x power n into f of x is equal to minus I whole power n into d power n by ds power n of f of s. This is the result already we proved in the first lecture. Okay, now here if I substitute n equal to 1, Fourier transform of x into f of x is equal to minus I whole power 1 d by ds of f of s. So this result I am going to use now. Okay, so in here x into f of x is what? E power minus a mod x. Okay, now Fourier transform of x into e power minus a mod x, which is equal to minus I into d by ds of f of s. F of s is nothing but Fourier transform of e power minus a mod x. So what is Fourier transform of e power minus a mod x? So equation number 1. So equation number 1 is what? Root 2 by pi, okay, a by s square plus a square. I'm going to substitute this value there. Root 2 by pi, root 2 by pi, a by s square plus a square. Now, which is equal to minus I, root 2 by pi is constant. If you differentiate a by s square plus a square with respect to s, you'll get minus a by s square plus a square whole square into, if you differentiate s square plus a square, you get what? 2s. So the final answer for this problem is minus into minus plus I into root 2 by pi 2as by s square plus a square whole square. S square plus a square whole square. So this is equation number 4. So that's all. So if you want, you can cross check our answer. I into root 2 by pi 2as s square plus a square whole square. Already I gave the same answer here also in the first slide. Yes, I into root 2 by pi 2as by s square plus a square whole square. So first problem is over. Next, one more problem we will discuss. Second problem. So in the second problem, find the Fourier transform of Fourier transform of e power minus mod x, e power minus mod x and hence find the Fourier transform of Fourier transform of e power minus mod x into cos 2x. So there are two parts again in the problem solution. So already we know that since the previous problem, but in the examination you need to derive, okay, but here you can write, okay, Fourier transform of e power minus mod x. In the examination we cannot write, okay, e power minus a mod x. First you should write e power minus a mod x, which is equal to what? Uh, Actually, root 2 by pi a by s square plus a square. Okay, root 2 by pi. I think in the equation number 1, okay, I should see here equation number 1 is what? Root 2 by pi a by s square plus a square. A by s square plus a square. But here a equal to what? 1. So, Fourier transform of e power minus mod x is equal to root 2 by pi 1 by s square plus 1. Now we should find what? Fourier transform of e power minus mod x into cos 2x. So for this also again we need to apply uh, properties that is we discussed in the first class. That is a modulation theorem. Okay, so next I'll write to find Fourier transform of e power minus mod x into cos 2x. Okay. So for this, I'll write the modulation theorem by first the modulation theorem is what? Modulation theorem is Fourier transform of f of x into cos ax is equal to 1 by 2 f of 1 by 2 is common, a function of s minus a plus function of s plus a, function of s plus a. Okay, so now I'm going to use this result. So this is your f of s for this problem. So Fourier transform of, I'll write in the next slide, Fourier transform of e power minus mod x, e power minus mod x into cos 2x. Here cos 2x is a equal to 2. Cos 2x, which is equal to 1 by 2, 1 by 2, function of s minus a. Function of s minus a means here a equal to what? 2. So for root 2 by pi 1 by s minus 2 whole square plus 1. Root 2 by pi 1 by s minus 2 whole square plus 1. Similarly, next plus f of s plus a. F of s plus a means a equal to 2 now. Root 2 by pi 1 by s plus 2 whole square plus 1. Root 2 by pi 1 by s plus 2 whole square plus 1. Okay, close the bracket. So which is equal to, so you can take root 2 pi, pi is also common. Okay, 1 by 2 root 2 pi by pi is also common. If you simplify this, what will get? 1 by s square plus okay, minus 4s plus b square is what? 4, 4 plus 1, 5, 5 plus 1 by s square plus 4s plus b square is 4, 4 plus 1, 5. So you can write this is equal to root 1 by 2 into root 2 by pi. So you can write this is s square plus 5, s square plus 5 whole square, a plus b into okay, a plus yeah, a plus b into a minus b. So here s square plus 5 is a, okay, plus b is what? 4s. So s square plus 5 whole square minus what? 4s whole square. So if you take LCM, okay, if you take LCM these two, now the numerator what is square plus 4s plus 5 plus square minus 4s plus 1. So you can cancel 4s, and then remaining you have what? 1 by 2 root 2 by pi. The numerator you have 2 times square plus 5. The denominator you have s power 4 a square plus 10 10 s square plus 25 minus 16 s square. Close the bracket. You can cancel this 2 and 2. So again we'll get root 2 by pi. So root 2 by pi. Remaining what? S square plus 5. The numerator. S square plus 5 divided by the denominator you have what? S power 4 minus 6s square plus 25. S power 4 minus 6s square plus 25. Okay, so this is the answer for the answer for what? Fourier transform of e power minus mod x into cos 2x. So I will stop here. So tomorrow we will discuss uh, of infinite Fourier sine transform and infinite Fourier cosine transform. Thank you. If you have any doubts, you can ask to me. Otherwise, we will meet tomorrow.